Dramatically increasing computing power is the key to sparking innovation. So instead of raising a lot of smart things or purely increasing learning, the key to modern innovation is high computing power. I can definitely say. I was planning to say that it can be viewed that way, but I can certainly say that. The essence of innovation is high computational power. I recently attended a press conference held at a hotel in Tokyo on July 19th. A Japanese startup company called ZYRQ. i3, a Taiwanese public organization said to be the world's top semiconductor technology company. There is an institute of industrial technology called ITARI. Both companies announced the establishment of water immersion cooling technology that will revolutionize data center cooling methods and the joint development of next-generation machines. A related signing ceremony was also held. This is the announcement of the next-generation cooling system developed by the genius Motoaki Saito. Isn't it amazing? I went there. Many TV stations were also present. As far as I know, people in important positions also came. That should be it. i3 Public Institution. The Institute of Industrial Technology is the largest research institute in Taiwan, with about 6,000 researchers. It was a signing ceremony for joint development with them. I would like to talk about the specifics of this mechanism in the second half, but I would like to talk about the premise of talking about this mechanism. This time I would like to talk about what presingularity means. More specifically, how does it become a presingularity? I would like to talk about this. I think so. First, I would like to talk about the world situation and Japan's position. Since the introduction of ChatGPT, the world's attention has focused on next-generation AI models called large-scale language models. Computing power has reached the point where it is referred to as money. It's several hundred trillion yen. Specifically, it is predicted that the amount of investment in the world of artificial intelligence will reach several hundred trillion yen. As the democratization of AI progresses, the possibility and certainty of its realization, in other words, the understanding and expectations for AI have increased. Investment in AI is overheating even more. That's the situation. It may be hard to imagine, but the kind of AI currently in use, i.e., large-scale language models, which can perform human-like reasoning, has the potential to revolutionize almost every industry. Bring about great progress. AI that thinks on its own, forms hypotheses, and repeats trial and error tens of thousands of times faster than humans, is beyond the scale of what we can imagine. I mean, we can't imagine. For example, it is impossible for us to grasp intuitively how much the Earth weighs. We can understand it numerically, but very few people can understand it intuitively. That's why people believe in various theories such as the flat Earth theory, but they are on completely different scales. I can't even imagine it. That's what it is. No matter how smart AI becomes, humans intuitively think that it will only be several times or tens of times more intelligent. In reality, it is possible to think and perform trial and error tens of thousands or hundreds of millions of times faster than humans. So the range that would theoretically be predicted to be possible will be surpassed in the blink of an eye. Moreover, it happens in every field of industry that humans have. What do we mean by industry? Medical care, welfare, education, media production, distribution, cars, mobility, housing, energy, finance. There are many things. A lot more. There are so many industries that I could list endlessly. This means that technological innovation will occur in all of these industries on a scale that we cannot even recognize. It's not about a scale of 50 or 100 years or anything like that. This is a story of a future that could be visible to us within the next few years, or at least within 10 years. Currently, most people have not noticed any changes in their lives or work due to the advent of modern AI. That's because humans haven't caught up. There are two reasons why humans cannot catch up with this progress. This is because humans, as mammals, cannot adapt to such rapid environmental changes. Another problem is that people do not understand the nature of modern AI. What are the characteristics of modern AI called large-scale language models? It refers to the property of linear evolution. If we compare it to a human being, the brain has a size of about 1400 cc, and the law states that the larger the brain, the smarter it becomes in proportion to its volume. We don't know if this is the case with humans either, because we can't do experiments, and no one has ever done it. For example, it is true that humans are clearly smarter than rats, but this definitely means that a big brain is smarter than a small brain. Similarly, one of the characteristics of AI is that it evolves linearly and becomes smarter in proportion to its size. There is no certainty that this linear evolution will evolve in proportion to eternity. I think if your brain becomes twice as big, you'll probably become twice as smart, but I'm not sure if you'll become 100 times smarter if your brain becomes 100 times smarter. They may be parallel somewhere. What happens if you make it bigger? In reality, it would be extremely costly and impractical. If you simply increase the number, the cost will become prohibitive. So the trend has become that we should not make it any bigger. The idea that AI may surpass the scale of what humans can think of and create things that humans can't even imagine at an incredible speed is not because AI will be several 10 times smarter than humans. For example, if AI becomes 10 times smarter than humans, it may create amazing things that humans cannot even think of, and it may become extremely intelligent. You might think so, but it's actually not. That's not the point of AI becoming smarter. Just imagine that. Suppose I create an AI that has the same thinking ability as me. And since that AI can of course be replicated, let's say we create 100 million people of me. At the same time, ask them to think about a problem or issue. For example, we will develop rice that can yield 10 times the current yield. Make copies of 100 million people and make them think. Suppose that 100 million people work together to exchange information and conduct research over the course of a year. This will surely lead to the development of rice that has 10 times the yield. Even if it's not me, it will definitely happen. By the way, I said 1 year, but since AI is a computer, 1 year can be shortened to 10 minutes. Our time cannot be physically reduced. There is a limit to what you can do in 1 hour. This cannot be increased. However, the time required for the computer can be easily shortened. This is another example, but computers also have a clock frequency. There is something called operating speed. It's like a heartbeat. Calculations are made accordingly, so the higher the frequency, and the faster the heartbeat, the faster the calculations can be made. It's just a matter of trying to do 10,000 calculations per minute instead of 100. This is a bit long, but the point is that AI doesn't have to be extremely smart to demonstrate extraordinary performance. Therefore, negative claims that smarter AI may never be born are misplaced. I think it can be asserted that what is called superintelligence due to AI is a fact that will definitely occur. In most areas of industry as we know it, the speed of progress is determined by AI, i.e. computational power. The more intelligent AI there is, the faster the industry will evolve. Because AI is computational power, the higher the computational power, the more our industry will evolve. That's how computing is today. Industrial development depends on it. There is still very little practical application of AI in our daily lives, so even in this modern age, where it is not so advanced, a lot of funds and engineers are concentrating on the development of AI. I used the human example earlier, but what determines the performance of this large-scale language model AI is its scale, which is the size of its brain. Therefore, companies and research institutions with more computing power are able to create higher performance AI. So there aren't many. It is said that some AI and LLM programs are being created in Japan, but only on a small scale. It's also very small. Not at all. The size of the brains they make is completely different. Japan's current computational resources can only do so much. Big tech is doing so much that it's eye-popping. In AI development, this big tech GAFAM has a monopoly. Without the amount of money and computers they have, this development would be out of reach. There's no point in trying. There's no point in trying was a misleading statement. Even if I do research, I can't get any results. If large-scale calculations cannot be performed, results cannot be obtained, and research cannot proceed. That's what happens. I think there are two factors that determine performance. One is to scale up or create a new architecture. This requires a little more detail and skill, but there are limits to what you can do. It requires some fine technique, but it can only go so far. While we are doing this little by little, emergence takes place over there, using tens of thousands of times more computing power. If you can do calculations, you can create something very clever. Everyone is completely absorbed in this thing. AI has such a structure. In the end, much of the performance is determined by the computational power and computational scale. Even if a fast F1 driver runs and rides, it will still be F1 speed. It's like that. Therefore, as a result, organizations with capital power, that is, many fast computers, are able to develop intelligent and high-performance AI. AI is said to be the final product for humanity, the last invention, the last development. Under such circumstances, the demand for computers has increased rapidly, and the company Nvidia, the largest semiconductor manufacturer, now has the largest market capitalization in the world. A story about what happens when the world demands computing power. I would like to think about that. I would like to think about what happens when a situation arises where computing ability is needed. Naturally, people and companies around the world want faster and more general-purpose GPUs for AI. Most of the general-purpose GPUs on the market are bought up by the big tech companies I mentioned earlier. Apparently, 2 million units will be produced in 2024. H100 is a general-purpose GPU named Hopper, but it seems that only about 10,000 units are supplied in Japan each year. By the way, this GPU called H100 originally cost about 3 million yen each, but it is said that it is currently being traded for more than 7 million yen. This sells really well. It's not enough at all. By the way, the H100, a general-purpose GPU for AI, consumes up to 700 watts of power. The reason is that I don't think it originally used much power, but when you want more computing power, you increase the operating speed and clock, or in other words, the more power you put into it, the faster it gets. Therefore, it seems that they are pushing it a little harder and increasing the operating speed to the maximum. However, increasing the operating speed to 700 watts reduces the computing power per power consumption. So, for example, if you increase the power from 500 watts to 1000 watts, it doesn't mean that the speed will double. This means that fuel efficiency will worsen. It gets hot. But we're testing the limits. Maybe. However, I want more computing power, so I want to increase the operating speed. At the same time, the operating temperature will rise, but we want more computing power, even at the cost of that, which is why we came up with this result. It seems that Nvidia's next generation servers, with over 1000 W per unit, will be released this year. But since the cooling capacity of conventional air cooling is insufficient, it seems that a water-cooled cooling structure will be introduced. But at the end of the day, you have to bring out the heat from the fan, which ends up making the room warmer. This air conditioning, including air conditioning, consumes a large amount of electricity. This water cooling makes the system more complicated. What's more, increasing complexity also reduces the reliability of computers. At the same time, problems are more likely to occur. Moreover, costs are expected to rise significantly. As a side note about cooling, among the substances used for cooling, water has a very high ability to remove heat, but there were also some that used diamonds. It will be used for Nvidia's GPU exceeding 1000 W. Probably a synthetic diamond. Make an artificial diamond of this size and attach it to the processor. Diamond seems to have the highest thermal conductivity. So I put that on and take away the heat. Apparently each one costs about 1 million yen. Therefore there was talk that the price of GPUs would go up just because of this. Moreover, there is a limit to the fact that even if you add it, it will not decrease much. In short, common sense suggests that what we have up until now is at its limit. This is a problem that cannot be solved without fundamentally changing the architecture. That's how big the demand is. Everyone is looking for computing power, but the situation is that we are not able to keep up with the needs at all. Even at this stage, it is not possible to meet the required computing power. It can be said that the world is in a state of exhaustion of computer resources. It's a situation where the more you have, the better. Next generation cooling systems are game-changing. And in this unprecedented situation, a company called ZYRQ, led by Motoaki Saito, has made a breakthrough to solve the problem of depleted computer resources. That is what was announced today, and what was revealed in this announcement is that ZYRQ and ITRI have signed an agreement to jointly develop next-generation data center cooling technology using a completely new water immersion cooling method. As we have discussed so far, with the current worldwide boom in generative AI, the demand for large-scale data centers necessary for its use and training is rapidly expanding. In any case, there is a lack of computational resources, that is, GPUs for AI. Creating a GPU for AI requires not only a huge logic semiconductor, but also a large amount of space to store a large amount of data, in other words, a place to store it once for calculations. High-performance memory is required to store large amounts of data. It's called IBM's cutting-edge stacked memory, and it can be said that Professor Saito came up with this as well. NVIDIA seems to have almost a monopoly on the memory market, and TSMC, the world's largest semiconductor manufacturer, produces most of it. In any case, there is only one company that can create one. The problem is not only that, but general-purpose GPUs that used to run at around 300 watts have now reached 700 watts and are now on the verge of reaching 1000 watts. If things continue at this rate, some estimates suggest that by 2030, the electricity used for AI data centers will exceed 8% of the world's electricity demand and could even reach 20%. Currently, data centers use only 1% or 2% of the world's electricity demand. You may think that it is already a large number, but it is about to increase to 10% or 20%. If this continues, it will be realistic. Almost certainly. I think 2030 will be even more amazing. Experience has shown that faster evolution occurs and demand increases. Furthermore, the heat generated by the GPU is tremendous, so it cannot be easily cooled down. Even at the moment, a lot of electricity and underground water are used for cooling. This is being consumed and is becoming a huge problem. This means that it is also an environmental issue. In the first place, semiconductors do not work if the temperature exceeds 105 degrees Celsius. This is because the expansion of parts can cause various problems. If the coefficient of expansion differs due to heat, materials may become displaced. That's why the problem occurs at 105 degrees. Even if it operates at this high speed, it is necessary to keep the temperature down to 105 degrees. In order to cool this, air cooling methods were used in the past, but even that has become completely impossible. We have even built cooling towers that utilize the heat of vaporization to cool the air, but this requires a large amount of water. There is a limit to this, and even if you use only that amount, you will not get a sufficient cooling effect. Therefore, liquid cooling methods and even liquid immersion methods were gradually developed. Immersion, or immersion in liquid, is the true strength of Motoaki Saito, and I think it's safe to say that Motoaki Saito is probably the most knowledgeable researcher and research group in the world regarding this technique. I won't go into details, but there is a company called Pezi that was headed by Mr. Saito. We use liquid immersion there as well, but there are liquids that do not conduct electricity and have excellent cooling performance. Fluorinert, a type of fluorinated carbon compound other than water, is used as a coolant to achieve the world's highest calculation speed. To go a little further, it's called Green 500, which competes in terms of computing power per power consumption, and is essentially a fast computer. Another point is that the larger the scale, the faster it becomes. So that's a side. Green 500 can be called a fast computer, because the competition is to see how much calculation it can do with this amount of electricity. We have a track record of monopolizing first to third place in the ranking that determines the ranking. That's why the immersion method created by Mr. Saito has such a good reputation. Since liquid immersion is the technology with the highest cooling performance and can be made the most compact, it has long been thought that this type of technology would eventually become mainstream. However, this fluorinert was a kind of pollution problem, and the company that was manufacturing it stopped producing it. This means that they suddenly became unable to manufacture it. When I looked into this, I found out that it had been the subject of a lot of news and discussion, and it was reported that the semiconductor industry had been shaken up. Therefore, it can be said that the industry relied on this to a large extent. In short, it is a liquid with fairly good performance. In addition to not having any effect on semiconductors, it had excellent performance and low viscosity, making it very suitable for cooling. However, This is very expensive, and floor inert, which is used for liquid immersion, can no longer be used. And currently, the development of this cooling system is centered on a new method called oil immersion, using synthetic oil or mineral oil. Oil has a high viscosity, so it can be difficult to maintain and can clog. In the first place, the cooling efficiency is poor, and it moves slowly. Naturally, the faster you move, the easier it will be to cool down. Therefore, due to such various issues, the oil immersion cooling system seems to be in a deadlocked state, not so much as it is being blocked in all directions. Meanwhile, Mr. Saito developed a completely new liquid immersion cooling technology. This is a cooling system that uses only water, something that was previously thought to be impossible. In the first place, pure water does not conduct electricity, but when it touches something, it ionizes and dissolves it. Therefore, it turns into a conductor and is difficult to maintain. We know that water conducts electricity. Speaking of water, it conducts electricity. You're not wrong. The water used in this system is tap water. A general-purpose GPU for AI is soaked in tap water and cooled into the water. That's amazing, isn't it? Because it's water, it gets very cold. Water has one of the best conductive properties among substances, and is a substance that absorbs a lot of heat. For example, imagine if you have oil that is 10 degrees Celsius, and you dip your finger into it, it won't be very cold. However, if you dip your finger in 10-degree water, it will be cold. This is because heat is taken away. It's a little hard to understand, so let me put it another way. It's not that cold when you lie on a carpet, but it's cold when you lie on a wooden floor. This is because flooring has higher thermal conductivity than carpet. Anyway, it's very suitable for cooling. Water is suitable for cooling things, but if it were possible to cool things down by soaking them in water, anyone would have done it. As I mentioned earlier, if you put an electronic board in water, it will instantly short out. It will break in an instant. There are many people who have experimented with it. I think they have tried various methods of processing the electronic board to make it more airtight. However, it costs a lot of money, and if water leaks, it's all over. So it's very risky. Therefore, until now, no such research has been conducted among experts. No one tried. As Saito-sensei told me, he had tried it once quite a while ago. He gave up on it for a while. But since there is no other methodology, he decided to research it. When Mr. Saito decided to try a water immersion system, even the engineers at ZYRQ seemed to think it was impossible. That's how insane it was. However, it is Mr. Saito who makes the impossible possible. We started development in February 2023, and within about a year, we have progressed to the point where we can conclude that it is possible. To date, we have reached a high level of perfection. There was also a real one, but it was quite complete. At that point, it had reached a functional state. The size was also very small. Anyway, Mr. Saito's originality is overwhelming. I'm really impressed. I am proud that I have solved many difficult problems with original ideas, but I am nowhere near as good as Mr. Saito. He has a wide range of knowledge and a flat perspective that is not influenced by bias. He is also a doctor of medicine, so I remember him saying that doctors have the best problem-solving skills. Even ITRI, one of the world's leading semiconductor research institutes, was surprised to see the development process. In the first place, it is not normal for ITRI to approach us and provide us with research facilities. It wouldn't be possible if it were normal. This is a rare level. I think it's fair to say that it's pretty amazing. Let's discuss the advantages of water immersion cooling systems in turn. The main point is that it uses only regular tap water, which is safe and inexpensive to use, as the main refrigerant. It is called a secondary refrigerant that is circulated externally, and instead of pumping water from a well and evaporating it, it pumps up groundwater and circulates it here first. Then, groundwater is brought in and cooled. Bring back that groundwater. In short, we are building a system that takes water from deep areas and returns it to shallow areas. In that sense, we are building a fairly independent system that uses a lot of groundwater and does not have a big impact on the environment. there is a specially developed heat conduction structure, which is a secret but interesting. It's a white substance with holes in it, and apparently water flows through the holes and cools it down. By developing and covering the GPU with a special flexible film that allows water to be applied directly to the GPU while keeping other parts dry, electrical shorts are completely eliminated. Although we are deeply immersed in it, we have established a methodology that properly protects the important areas. It seems that the material used for this is very difficult, so a new special film was created. This is a special product that will not leak water even after long-term use. We have created something that can guarantee so-called watertight performance for a long period of time. I think this is the most amazing thing. They also devised a device that has a structure that does not exist in existing technology and has the ability to remove heat, allowing the temperature of the GPU to drop to and maintain it by 25 degrees. Current water cooling can only control heat up to a temperature of 90 degrees or 80 degrees, but it can maintain the temperature at 25 degrees. The temperature of a 1000W class GPU, which was previously impossible, has been lowered to 25 degrees, allowing stable operation. Depending on the type of GPU, this can reduce power consumption by more than half. On the other hand, the electricity required for this water immersion cooling method to function is very low. As I mentioned earlier, even if you water cool the GPU, you will have to run a lot of air conditioning to cool it, and you will need a very large facility to pump and evaporate the water. Another reason is because it's big. In addition, it seems that various efforts were made to make it possible to go from requiring a lot of electricity to using less electricity. In any case, it is now possible to cool a very large amount of heat in a very small volume. This means that it currently has approximately 10 times the cooling capacity compared to other modern cooling methods. Therefore, by introducing this system, the size of a conventional data center can be reduced to several tenths of its size. To put it simply, let's say that the supercomputer Fugaku is roughly the size of Tokyo Dome. The image is that it can be made to the size of 2 containers. This allows you to quickly ramp up large numbers of large and small systems as needed. It would take a lot of time to make something that big. However, with this system, it is very small and can be built and installed quickly. This also creates a huge advantage. This is a story about how many benefits can be gained by cooling. Let me explain what will happen if this system is implemented. First of all, it is true that this technology is a revolutionary cooling technology that has been recognized by the world's top research institutes. In the first place, cooling is a very difficult thing. Cooling is extremely difficult. It's difficult. If I had the chance, I would like to feature just cooling. Aside from that, this level of cooling technology is an invention that will fundamentally change the way advanced semiconductor manufacturing technology works and how it is done. To put it simply, the higher the performance of a semiconductor, the more power it consumes. But it also means that it generates more heat. Therefore, current semiconductors require extremely high costs to ensure stable operation even under conditions of 100 degrees Celsius. In short, 100 degrees is very hot. If it were a normal computer, it would become a little unstable once the temperature exceeded 70 degrees. Many things are necessary for stable operation at 100 degrees. We need various ideas and various techniques. It costs money anyway. If we use the water immersion cooling technology developed by ZYRQ, we will be able to operate this at a temperature of 25 degrees. If this becomes possible, it will be possible to manufacture advanced semiconductors with cheaper and simpler designs. You don't have to be so careful. That's why it's so simple to make. Of course, it can be made cheaply and quickly. Specifically, if 10 million semiconductors can be operated at room temperature, the semiconductor design itself can be completely redesigned, reducing the cost of semiconductor design and reducing the semiconductor area. The power consumption of the semiconductor itself is also reduced. Furthermore, we can expect improvements in the operating speed of semiconductors. If it can be cooled, there are various two-dimensional and secondary benefits. And these benefits are huge. Each one is extremely large. This has a world-changing impact. Furthermore, when we talk about semiconductors today, in terms of precision, they have been miniaturized to something like 5 nanometers. And now, these semiconductors are gradually transitioning to 3 nanometers. In other words, their performance is being improved. Moving to 3 nanometers means increasing the density of integration. It's becoming incredibly packed. That's what moving to 3 nanometers means. Therefore, current 5 nanometer semiconductors are gradually shifting towards 3 nanometers. Even though they are made at 5 nanometers, the possibility has emerged that semiconductors with sufficient performance can be produced. Since we are in a state of exhaustion, there is also the advantage of being able to use vacant equipment more and more to further increase production efficiency. Speaking of supercomputers, even if the cooling system were to be water-cooled, a pipe would pass around the semiconductor, something would stick to the semiconductor, and water would flow through it. At the end of the flow, the water flows finely and minutely, and there is a fan called a radiator that cools the water by passing air through it, and brings the cooled water back to the GPU, where it is drawn out further. This is what we do. After all, that warmed air is further cooled by the air conditioner. That's what I'm doing. So there are two problems. It uses a lot of electricity, and the other is that it has to be cooled down in stages, so not much water gets through. This means that we are not using a large amount of water. We have to distribute what is supposed to pass through thin pipes. With the current method, we end up with only a small amount of water circulating. However, if you immerse it in liquid, it becomes very seamless and allows you to circulate a larger amount of water. So, naturally, the cooling efficiency will also improve. That's the story. As I said at the beginning, computational ability is the thinking speed of AI itself. At the same time, multiple AIs can run in parallel and perform trial and error many times faster than humans. The next generation cooling system, announced this time, will enable an ultra-compact, ultra-fast AI general-purpose GPU. In any case, it is thought that the Presingularity will accelerate from here. What makes us human is our technical ability. Technology refers to something that has been generalized so that everyone can use it. It may be a little difficult to understand, but that's what technology is all about. In the first place, technology is about creating methodologies and making things usable by everyone. In other words, humans have been able to strengthen the human race as a whole by immediately sharing what someone discovered or invented, and by equipping and using it with everyone else. That's why we are number one. Since a computer the size of Tokyo Dome is now the size of a container, it can be easily placed in various locations, and moreover, many researchers will be able to use an abundance of computing resources. You will be able to do things that you could never do before. Naturally then, both in Japan and around the world, everyone will be able to conduct trial and error. This will increase the number of people involved in trial and error, leading to further technological breakthroughs. That's what happens. There's more. The modern AI we've seen so far has been humanity's final product. It's a product that solves numerous problems, invents, and creates on behalf of humans. The AI known as LLM, or large language model, is a fundamentally different and unprecedented product that evolves in a linear manner. I don't think there has ever been a product that evolves in such a linear fashion. For example, do you remember around November last year when an AI called Sora, which generates images from words developed by OpenAI, was announced? That's Sora. People might wonder just how incredible it is, how much trial and error went into its development, and how much innovation was involved to create something like that. But actually, that's not quite the case. In simple terms, they kept making the image-generating AI bigger and bigger. The number of parameters increased, and the complexity grew. It was like making its brain bigger and bigger. And as a result, it suddenly became capable of doing things like that. It even follows the laws of physics properly, and can now generate high-quality videos, one after another. That's the story of how something like that came to be. So, what I mean by emergence is that, although it may be a bit of a misnomer, I just put money into it. If you throw money at it and pack a lot of computing power into it, you can do it. That's what it means. I think Sora is very innovative, and that's what it comes down to. Therefore, today's AI is a heterogeneous product that evolves linearly. Dramatically increasing computing power is the key to sparking innovation. The key to innovation today, rather than simply nurturing something smart or simply improving academics, is high computational ability. You can say that. I was going to say that I could see it that way, but I can say it with certainty. The essence of innovation is high computational power. Therefore, if an ultra-compact supercomputer equipped with Mr. Saito's water immersion cooling system is realized, in addition to the technological innovation inherent in humans, technological innovation caused by AI will also be accelerated. So this timing is perfect for Singularity. Or, the person who truly caused the Singularity may be Motoaki Saito.